So today we shall discuss about operation of real numbers. Operation on real numbers. See, we already know that we can how to add the two rational number, how to separate the two real number, how to multiply, how to divide, and we know that the addition of two rational number is always rational number. The subtraction of two rational number is always a rational number. The multiplication of two rational number is always a rational number, and the division of two rational number also always a rational number. Now, in case of irrational numbers, when you add two irrational number, result not always irrational, sometimes may be rational. Similarly, in case of multiplication, division, subtraction, when you do this operation on irrational number, result may be rational or may not be rational. It means it may be irrational. Let us discuss some examples. For example, suppose I shall select two irrational number, 2 plus root 3, 2 minus root 3. In case of addition, now add it. 2 plus root 3 plus 2 minus root 3, we shall get 2 plus root 3 plus 2 minus root 3, cancel, we shall get 4. Now see here, addition of two irrational number is a rational. Similarly, also we can prove addition of two irrational number is irrational also. See how? Let us take two examples. Suppose I shall take root 3 plus 2, root 3 minus root 3 plus 3 plus root 2, 3 minus root 2. 3 plus root 2 is an irrational number, 3 minus root 2 is also an irrational number. Now add them. 3 plus root 2 plus 3 minus root 2, that is 3 plus root 2 plus 3 minus root 2, cancel, we shall get 6. Here, result is also a rational number. Now, you take another example. Suppose root 3 plus 2, root 3 minus 2. This is a irrational number, this is a irrational number. Now add them. So root 3 plus 2, root 3 minus 2, cancel. Result coming to root 3, which is an irrational number. Now in this case, we got that addition of two irrational number may be rational, may not be rational. It means it is irrational number. Similarly, in case of subtraction also we can get subtraction of two irrational number, sometimes rational, sometimes irrational. Now come to in case of multiplication. Two plus root 3, 2 minus root 3. These are the two irrational numbers. Now multiply them. 2 plus root 3 into 2 minus root 3. Result coming. It is a plus b, it is a minus b. So you apply formula. A plus b into a minus b is a square b square. Now apply it. 2 square minus root 3 square. That is 4 minus 3 is equal to 1, which is a rational number. Similarly, you take another example. Take a root 2. Root 3 is an irrational, root 2 is irrational. Their multiplication is root 6, which is an irrational number. So here, product of two irrational number is rational, but here product of two irrational number is irrational. Similarly, in case of division also you can get the division of two irrational number, sometimes rational and sometimes irrational. In this way we can prove it. Now, suppose a question is given it 1 by root 3. I shall tell you rationalize the denominator. Can you rationalize? See how to rationalize. 1 by root 3. So denominator is root 3. It is an irrational number. We shall make it rational. In which way we can make it rational? So we have to see what is its rationalizing factor. For root 3, the rationalizing factor is another root 3. It means 1 by root 3 multiply here root 3. The same you multiply in the numerator. So result coming 3. So 3 is rational. In this way we can rationalize to a denominator by multiplying its rationalizing factor. Similarly, suppose I shall take root 5, written 2 by root 5. Now rationalize the denominator. It is root 5, its rationalizing factor is another root 5. So multiply root 5 in the denominator, the same thing multiply in the numerator. So result coming 5. So rationalize the denominator. This is in case of monomial denominator. If the denominator is monomial, you can get its rationalizing factor like this for root 5, for root 3. So denominator is rational number. Now in case of binomial, suppose I shall write here 2 plus root 3. Denominator is binomial. You have to see what is its rationalizing factor. Since it is written in terms of a plus b, so its rationalizing factor is a minus b. If the denominator is a minus b, then its rationalizing factor is a plus b. Now it is in the form of a plus b, so we multiply a minus b. Just multiply a minus b. The same thing multiply in the numerator. So we shall get 2 square minus root 3 square, here 2 square, coming 2 minus root 3 by 4 minus 3, that is 2 minus root 3 by 1 in case of binomial. So if the denominator is trinomial and denominator is irrational, in this way you can find out it, you can rationalize the denominator in this way. Now some questions say root 3 plus root 7 plus whole square. Simplify. So this is the question. How to simplify it? You see, it is in which form? It is written in a plus b whole square form. Do you know what is a plus b whole square? Apply that rule. A plus b whole square is a square plus b square plus 2 into a into b. That is 3 plus 7 plus 2 root 21. It means 10 plus 2 root 21. Simplify. So another question given, 2 or 3 plus root 5 into 3 minus root 5. Simplify it. You see, can you apply some identity? Is it in the form of any identity? You see, it is, if you take it is A, it is B, it is A and it is also B. A plus B, A minus B. What is the formula? A square minus B square. So that is 3 square minus root 5 square. It means 9 minus 5, that is 4. Simplify. Another question. Rationalize the denominator. Already we discussed how to rationalize the denominator. Now, one more question is here. Already we know that how to represent the rational number on the number line. How to represent the irrational number. How to represent the irrational number, that also we discussed. Now, if you get an irrational number like this, so how to represent? So question is, suppose an irrational number is like this, root 12 of 6.3. How to represent on the number line? It is important. It is a new type of questions. How to represent? You see. So let x is equal to this. You might take it for proof. It is essential. Let x is equal to this for proof. But how to represent? Only how to represent roots of about 6.3 on the number line. You see. First, draw a number line. Then it is 0. By the help of scale or rounder, cut 6.3. Suppose up to this coming 6.3, up to 6.3. Now take 1 unit more. Here take 1 unit more. OH 6.3. OH 6.3. Now take 1 unit more. So we shall get OB. Now find out the midpoint of OB by drawing its perpendicular bisector like this. This is the midpoint of OB. Now taking OH center, either OB or OH radius, draw a semicircle. Now at point A, draw a perpendicular. This length gives you root over of 6.3. Now taking a center with this as a radius, draw an arc. It caught the number line at this point. This point P represent root over of 6.3. Root over of 6. This length indicate root over of 6.3. This length same. So this length, only this length indicate to root over of 6.3. This length and this length same. Now homework based on this part, the homework is exercise 1.5, question number 2, question number 2, question number 4, question number 5. This is your homework. 3 questions given to you. Other questions are very easy. We already have discussed it.